Hello guys, so welcome to your channel which is Science Engineers. This is Sushant. We have been uploading videos for your basic electrical engineering, applied mathematics and engineering mechanics. We will be doing so in the near future also. So to get them you need to just subscribe to our channel, hit the bell icon to never miss a notification, and do like our videos and share it with your friends. The sharing and liking will help us make more videos and inspires us to make more videos like this. We are associated with the Samartha Vidya group tuitions, which is for engineering and science students. So if you want to inquire about us, you can just email us at samarthavidya@gmail.com, or you can visit our Facebook page, which is for Samartha Vidya. So let's get going with today's topic. So in this particular video, we're going to continue with our discussion on AC circuits, wherein we'll be continuing the discussion on the problem solving part of the AC circuit. We have already seen how different elements behave in the AC circuits, like our resistor, our inductors and capacitor, and also seen some of the combinations which are possible in it. We'll be seeing some of the sums which will be related in this and how to solve them and how to analyze. So let us consider this problem which is given to us, in which we have a coil which is of resistance 10 ohms and an inductance of 40 millihenry, which is connected to a 200 volts and 50 hertz supply. We have to calculate the impedance of the coil, the current, the power factor and the power consumed by the coil. So let us try to understand this particular problem. So we will be first trying to draw the figure for this, that is a circuit for this. In this they have given me a coil. So coil, whenever a coil is mentioned, you have to understand that the coil is not going to be a purely resistance or a purely inductance. So it will be a combination of a resistance and an inductance. So whenever you are having a coil, so if it is mentioned, then accordingly you will be drawing a resistor and an inductor, which will be representing totally our required coil. So this part is the coil which is given to us. This particular coil is given to a supply of 200 volts and 50 hertz. So obviously it's a AC voltage which is being provided over here. Now the voltage which is mentioned over here is basically the RMS value of your voltage, unless it is mentioned like VPP or V peak to peak, then it should be assumed that it is going to be my RMS value. So the RMS value of the voltage is given by 200 volt and my frequency is given by 50 hertz. They have given me the resistance value and the inductance value. So R is given as 10 and my inductance, which is given by L, is equal to 40 millihenry. Now what I have to do is I have to calculate the impedance of the coil. So my impedance of the coil is given by Z, which is equal to my R plus J X L. We have already discussed this particular part. You can see that there is a resistor and an inductor which is in series with each other. So your impedance will be given by just the addition of the resistor and the equivalent resistance of my L, which is called as my inductive reactance. So I have to first of all calculate what is going to be my XL. So my XL is given by the formula, that is omega L, which is nothing but 2 pi into F, which is 50 over here, into L, which is 40 millihenry. So after calculation of your XL, you are getting my Z is equal to 10 plus J, 12.57 ohms. So that particular value is in your Cartesian form. So you have to convert it in your polar form. So that is going to give you the value of 16.07 angle 51.5. This is also going to be your units in ohms. So this is your first part which is asked, which was impedance of the coil. So you can write this as Z coil. Now the next part is you have to calculate the current of this particular circuit. So you can see that the current in this case is going to be flowing throughout this particular circuit. So your current will be given by the voltage applied divided by the total resistance or the impedance in this case. So you will be having your voltage which is 200. The angle for this voltage is going to be 0 divided by the Z value which is 16.06 angle 51.5 degrees. So when you're calculating this, you have to remember that you have to just divide these two, and this will be just subtraction of the angles. So the I is given in this format. So you have calculated the current which is flowing through it. The next part is called as my power factor. So power factor is given by cos phi, where phi is nothing but the phase difference between the current and the voltage. You can see that my voltage in this case was assumed to be the reference point, so we had taken it as 0. My current was having the phase as minus 51.5, so that is why my power factor will be given by cos of 51.5. So you will be getting your power factor as 0.62. Now since the angle over here for the current was negative, so this power factor is to be written as lagging. So that is the last, coming to the last one, which is the power consumed. Now the power consumed, you have to understand, is going to be only because of the resistance present in the circuit. So the power consumed by the coil is going to be given by the power lost by the resistor. So that is going to be PR is equal to I square R. So in this case, you are going to take the I only this magnitude part of it. So it's going to be 12.45 square into the resistance R, which is given by 10. The power loss comes out to be 2 kilowatt. So this is how you will be trying your problems based on your RL circuit or your RC circuit. We'll be seeing one more problem based on it to understand it more. So let's see this particular sum which is given to me. You can see that they have given me the equation for the voltage which is present in the circuit and the current which is flowing through the circuit. This particular voltage is applied to two elements which are present in series in this particular circuit, and I have to find what is going to be the resistance, the reactance, and the power factor. So in this case, they have not mentioned what is the elements present. One of the element we can guess is going to be the resistance part, but the other is not mentioned whether it is going to be the inductance or the capacitance. So what we need to do is we have to start with the given part which is there. You have the equation for your voltage, so you can convert it to your phasor form. So this is going to be E bar is equal to, or it can be written as V bar, that is your voltage, that is a phasor voltage, that will be given by 100 by root 2, because this is going to be the peak value for your voltage, and whenever you are representing your phasor, you have to represent the RMS value of your voltage. So that is why V bar will be 100 by root 2, and the angle given for this is given as 30 degrees. In the same manner, you will be representing your phasor for your current, which is going to be equal to 50 by root 2, and the angle given is 60 degrees. Now we have to find the resistance, the reactance, and the power factor. So for that, first of all, we need to find the impedance of the circuit. So my impedance of the circuit will be given by your V bar upon I bar, which is nothing but 100 by root 2 angle 30 degrees divided by 50 by root 2 angle 60 degrees. So the root 2 parts gets cancelled, so you're getting this as 2, and the angle you're getting it as minus 30 degrees. So this is in ohms. This is your polar form, so you need to convert it in the Cartesian form. So you're getting the Z as 1.73 minus J ohms, which is in the Cartesian format. Now in this you have to make one observation. You are getting a negative J. That means that this particular element, the other element which was unknown, is going to be the capacitance which is present in the circuit. The negative J indicates the capacitance whenever you are calculated your Z, and a positive J will indicate a inductance which is present. So we will be comparing this equation because your Z bar, when you have a resistance and capacitance present, then in that case your Z bar is given by R minus J XC. So you will be comparing it with this, so you will be getting the resistance as 1.73 ohms and your XC which is your and your XC which is your capacitive reactance is going to be equal to 1 ohms. So we have calculated your R, we have calculated the reactance, we have to calculate the power factor. So the power factor in this case is given by the angle which is present over here, so that's cos of 30 degrees, so which will be equal to cos 30 is root 3 by 2. Now since we have a capacitance which is present, your power factor will be leading. You have to remember that power factor, the leading and the lagging part is given by the current which is present. If my current is going to lead the voltage, then it will be a leading power factor. If my current is going to lag the voltage, then it will be a lagging power factor. So if you are having a capacitance which is present in the circuit, the net effective capacitance present in the circuit, then your power factor will always be leading. If your net inductance is going to be present in the circuit, then your power factor will be lagging. So that's all for today. We'll be discussing more problems based on this. We'll be discussing the new topic which is your RLC circuit, wherein we have all the three present in the circuit and how to analyze them, and some concept which is called as resonance of a circuit. So for that you need to just subscribe to our channel and hit the bell icon so that you never miss a notification. You just need to like our videos and share it with your friends so that it helps us make more videos like this in the coming future. So to know about us, you can just email us at samarthavidya@gmail.com, or you can visit our Facebook page which is for Samartha Vidya. So we are from Samartha Vidya, which is for group tuitions for the engineering and the science students. We have been helping students for the preparation for the first and the second year engineering, and also for their engineering entrances. We have also helped students for their board exams for the 11th and 12th. So for now, we are signing off for today. So this is Sushant. So keep learning, keep watching, and happy learning. Bye.